Hey everybody, this is Alex Merced from Alex. We're going to go in depth with scope and really kind of help you understand scope to the max. So, okay. So first let's just start with like variable declarations, okay? And understanding their scoping and their behavior. So the old school way of declaring variables was var, okay? And var, and like, a lot of the older JavaScript stuff works funny or is like less predictable, um, which is why a lot of it is replaced, or like a lot of it we use more modern ways of doing things. But understanding the old behaviors still matters. So I'm just gonna get myself in the right folder, cd practice. Okay. So if I declare a variable, I just be like not var my var equals 5. And then if I were the console.log my var, it's going to equal 5. Let's just test out our code before we start getting too deep into this. Save. There you go. Okay, node my var. No, node testing. And see, I get 5. Okay. Now let's show you something interesting. Okay. Let's say I did this. Cut. So now I don't declare my var until after the console log. So usually you'd think this is going to give you an error saying my var is not defined. But watch what happens. I get undefined. So I don't get an error, I just get undefined, as if the variable already exists. This is because of how the JavaScript interpreter treats this declaration, specifically with the var keyword. Okay, what it does is that when it sees the var keyword, and that's my bird in the background, you might hear a little bit. Okay, what it does is that it basically changes the code and interprets it this way. Okay, so basically you saw what you just saw, but in the eyes of the JavaScript interpreter, it sees this. Okay, it picks up on that declaration and moves the actual declaration, the var keyword, up to the top. So the variable exists, even though I don't assign it to line 5, which is why I get the undefined, the variable magically exists. And this is the kind of weird, unpredictable behavior, which is why people generally don't use var anymore. Okay, so that's the first piece of information regarding var. Now, what do people use instead? They would use let. So now, let's just so you can see the difference in behavior. If I did let, I hit save, I get an error. My var, I can't access the variable before I've initialized it. Okay, I didn't create it till line 3, so it's like, you can't use this. Okay, so const and let, sort of the newer ways to declare variables, not that new, but newer, they were made to like, basically what you wrote is what's happening, in the sense that if the variable doesn't initialize until you actually declare it in your code, instead of that weird sort of assumption of declaration that you have with var. So that's like sort of the first sort of weird issue between the two. So with let, I know my variable doesn't exist until I actually use let or const. With var, it kind of exists beforehand, and that could theoretically maybe cause some sort of weird collision somewhere. You know, these are things you have to worry about. Okay, so now actually to scoping. So scoping is about like, where does the variable exist? Now when you declare a variable with var, it always falls into one of two categories. It either exists everywhere, so it's global, okay, or it's function scoped. There's no block scoping with var. So basically if I do this, if 5 is greater than 3, then var cheese equals 5 console.log cheese. Okay, what am I going to get? It's just going to console log 5. Okay, because var is global regardless. Okay, there's no block scoping. While like const and let, they're block scoped. So they only exist within the the brackets. So they're looking for brackets. They don't care if it's a function, if it's an if, or if it's just arbitrary brackets. And I'll show you that in a second. When it's let or const, okay, and I'll make this const cheese just because I used that last time. Const cheese, it only exists with, it's going to look for the curly brackets that it's in, and it only exists within that set of curly brackets. Okay, so save. So if I do this, okay, cheese is not defined. So even though I console log cheese, and when I did var, it printed just fine, const does not, because there the scope is always within the block, not function or global. It's block, 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 block. Okay, and again, it doesn't have to be a particularly useful block. I could literally just put curly brackets randomly in my code, and now that variable only exists within that block. See, I still get the same error. Okay, so that's another big difference. Okay, now when you're within a function, this distinction kind of disappears because var can be function scope, where it only exists within a function. So let's see here. Let's create a function. Const my func. Actually, let's use the old school function syntax. School my func. And no parameters. We'll just say const. We'll just say var cheese equals 5. Okay, and that's that. So then we will run my func. We'll invoke the function, so the function happens, and then we'll console.log cheese. And this won't work regardless of the type of declaration, because for var, a function is considered a separate scoping. So there's global scoping as long as the variable is declared outside of a function. Once it's in a function, it only exists in that function. For const and let, it has the same effect, except it's the brackets. It's the curly brackets that are keeping it within the function, because it's block scoped. But at the end of the day, the result is the same. So when you're in a function, everything stays inside the function. Okay. Cool. Okay, so that code is just not going to work. Interesting. Okay, and then there's something weird about function scoping as well. And this gets into sort of, newer function syntax versus older function syntax. So when you declare a function using this syntax, kind of like how we would kind of put the interpreter puts the var up at the top. So let's say I do this. I'm going to cut this whole function out, put it way down, and then I'm going to call it up here. My func. Now usually you'd think, this doesn't make any sense. My function doesn't get declared till down here, yet I'm using it up here. This should cause a problem. But this particular syntax, because it's sort of the original sort of syntax for functions, the old school JavaScript behavior was to just sit there and look for these keywords and kind of move stuff around without telling you. So really what's going to do, it's going to see this function and just move the whole function up to the top. So then the function will work. Okay, so you see I get cheese is not defined. Wait, let's see here, and run the code. Node testing is not defined. Oh no, it works because the function is the code is working. So you see it ran, it didn't run any errors because I used that function style. I didn't actually print anything on the screen. So just to make that clear, let's just do console.log 5, just so we can see it work. So see, the function works even though I called it before it's defined in the code, because the JavaScript interpreter will pick up on those functions, move them up to the top, so that way they're declared before the invocations. But in more modern JavaScript syntax, you might find one of these kind of, instead of actually using the function keyword, what you're doing is you're using a variable declaration. You might be using var myfunc, and then you do something like equals function console.log 5. Now this won't work because it's going to treat it the same way a var works. So what'll happen is that myfunc will be undefined. It's going to essentially take the var myfunc, put it at the top, but the function, the actual assignment of the function into the variable stays on line 3. So it'll just be like, huh? So let's do no testing. Okay, it'll say myfunc is not a function. See, it doesn't say myfunc is not defined, because we used var, and var moves the actual declaration to the top, keeps the assignment where it is. And so there's no function in that variable yet. And see, that's really confusing. That's really silly. And that's why no one uses var anymore. Okay, and why people don't really use that old school function syntax anymore, because it's confusing. Now, another way this could be done is you could do it through a let. So let's see what happens if I did let. Because again, a let isn't going to move the declaration to the top. So will I get the same error? Let's see. Okay. Here, I get the same thing before. Hey, the variable doesn't exist yet. You can't use it. So now it's not telling me that it's not a function. It's just telling me the variable is not available to use yet. Okay. Because again, let, the initialization stays where it is in the code, which is nice. That's why we like let and const, because whatever I have in my code, that's what's happening. So I just have to look at my code, and my code is what I wrote. It's not going to do some weird behavior behind the scenes, like var and the old school function syntax. Okay, cool. So again, just to kind of show you some of these weird behaviors. Okay. Now the thing is, we can take it a step further. Okay. With scoping, like how can we break scoping? So you might have seen some of my previous videos on closures, but the closures idea is where you're basically manipulating function scoping. So we know any variables we declare inside a function exist within that function. But if you declare a function in that function, so for example, const parent. Okay, and actually I'll just use old school function syntax to keep this easy. Function parent. So there's the parent function, and then we're going to declare a variable const 5 equals 5. And then what I'm going to say is that this function returns another function, and this function, what it does is console.log 5. Now let's think about this. So this variable should have block scoping, so it exists within the curly brackets it was declared in. So it exists throughout this. So even though this function is declared inside of here, it has access to 5, because in the area in which it was declared, that variable existed. Okay, so it's in scope. But watch this. So let's say const 5, because again 5 doesn't exist outside of this square bracket yet. Okay, so technically outside of this curly bracket there is no 5. So I'm going to declare 5 again. But I'm going to say it equals the result of the parent function. And what's the parent function going to give me? It's going to return this function. So it's actually returning and storing a function in this new variable called 5. And then if I were to run 5 as a function, because now there's a function in there, it console logs 5. And where's that 5 coming from? Here. And technically this 5 should not have scope outside of these curly brackets. It should not be able to exist outside of the use of this parent function, which has already happened. The reason it happens is because technically this function that's stored in here was created within those curly brackets. So technically it has access to all the variables in scope where it was created. This pattern is referred to as a closure. Okay, a closure. So that's what that is. Okay, so that's a cool thing you can do. So again, you can return functions that allow you to manipulate data that's declared within a function, and you can almost use it to make functions act as like objects in a sense. But that's another sort of weird scoping thing. Okay, now another interesting scoping issue, and this is not so much scope more than just sort of again a way data moves around. When you pass a function when you pass data as an argument, some data gets copied. So for example, let's say here I do const, my num equals 5. Okay, and then I do function num return num plus, or we'll just say num equals num plus 5. And then we're going to return num. Okay. Cool. So then basically what happens if I do this function, or I actually give the function a name. That would be kind of useful. Function myfunc. Okay. So if I do myfunc and pass in my num as an argument, then technically my num replaces num. But here's the thing. Since my num is a number, so it's a primitive JavaScript value, it's going to make a copy of it. So technically what I'm num just becomes a copy of my num, becomes a copy of 5. So technically when I work with it inside the function, I'm not editing the original my num. So when I do num equals num plus 5, I'm only manipulating or mutating the copy of the argument. Okay? So in that case, when I return num, so just to let's actually wrap this in a console log so we can see the results. So I'm going to console.log my num as a result of my func invoking and passing my num as an argument, and then I'm going to console.log my num separately. And you're going to see that it'll be like 6 and then 5. Because even though I manipulated the number in the function, the original variable that I passed in doesn't get changed because it didn't pass it in, it just made a copy of it. And the function was working with a copy of the data. Okay? Oh, so 10, 5. Okay, so that's, and that would work with, basically it should be the same case for, let's see here, should be with a Boolean. Okay, I'm not sure how this would be treated, but I guess this would be true. I don't know. Okay, but it should be the same thing. So when we print my num, it'll still be true, despite what happens inside the function. Okay. Got it, because true equals 1. Okay. So you see, still doesn't manipulate the original value. And if I do a string, okay, see string 5 from the function, but see the original string is still untouched. So when it's a primitive value, a single piece of data, it doesn't manipulate what's inside of it. Okay? But when it's an array or an object, things get a little bit different. Okay? The reason being is that an object and an array, okay, and which an array really is at the end of the day a type of object, they are not, the variable doesn't actually hold the data. Okay, so when you have like a, so if I sit there and create an array, so we'll say my r equals, let me pause this. Okay, there we go, siren's gone. Now let's see here. So if I do my array, and we'll say my array is 1, 2, 3, and I pass in, then we're going to just say here and say, we'll just edit the first value. So we'll just say the first value of the array 0, index 0 equals index 0 plus 5. Okay. And then we're going to, again, pass in the array into the function and then console log the array by itself afterwards. Watch what happens. So before, when I reconsole logged it, the original did not change, whether it was a string, a Boolean, whatnot. But when I do, okay, when I did it as an array, see the first value did change. Because again, it started out as 1, 2, 3. The function changed it to 6, 2, 3, and the original, when I console logged it, was changed. The reason being is that the variable, again, doesn't hold the actual information. It holds a reference to where the information exists. So yes, it's making a copy of the variable, but it's just making a copy of the address of where the information exists. It's still the same information that exists at that address in your memory. Okay. In other languages, it's referred to as a pointer. It points to where this information exists. Okay. In other languages, arrays would be copied. Okay. An array would be copied. So your function wouldn't actually alter the array. You would make a copy and then you would do your function stuff. If you wanted it to be altered, then you would pass a pointer to the array, a pointer to its memory address. But because of the way JavaScript works, that's just assumed when it comes to arrays and objects. Okay? So the variable is actually the reference to the array. Okay, and the reason why this is important is because this creates some really bizarre scoping issues. Okay, but first we'll finish this whole function piece, and then we'll go back to non-function world. Okay, and this would be the same thing with an object. So if I were to make this an object, okay, so that's well, first let's just finish the array situation. And what if I don't want that? What if I wanted to make a copy of my array? I want to pass a copy of my array into the function because I don't want it to alter my original array. There is a way to do that. What you would do is you would just do this. You would pass an array, so you use square brackets so that way it's a new array, and you would just use the spread operator to pass in your array. Because then what happens is that when you do that, whenever you use square brackets, it's creating a new spot in memory where a new array is going to be created. And then what's it going to store there? The same information that's inside my array because you did the spread operator. So in that case, it's a copy of your array located in a different address in memory. So you're passing a different address. So it doesn't affect the original one. So when I do this, now we should get back what we kind of got used to, where, see, the original is unchanged. So keep that in mind with arrays. If you just pass in the full-on array, it's going to get mutated into a function. If you want it to not be mutated by the function, then you might want to do something like that. Okay, use the spread operator. And it's going to be the same thing with an object. So let's do the object version now. So first, we'll just change this to my obj. And then we're just going to do an object with one property. Name Alex Merced. Okay. And then what we're going to do is we're going to change the function. And we'll just say num.name equals Hector Merced. Okay, and then we're going to pass in my obj into the function, console log the result, and then we'll console log the original array again. So when I do this, let's watch what happens. See, the original was altered. When I went back and console logged the original, it still had the changes from the function because it's passing an address. Again, this is the difference between passing the value, a copy of the value, versus passing a copy of a reference. Okay, strings, numbers, booleans have a value in the variable. Objects and arrays have a reference in the variable. Okay, and when you really appreciate that, it really kind of clears a lot of things up. Okay, so now if I wanted to avoid that and not pass in a reference or the current reference, I want to pass in a copy to a new object with the same property so I don't get the mutation, then what I do is in the function I would just do this. Use curly brackets so it creates a new object, and then once again just use the spread operator so that way it has all the same properties. And when I do this, now we'll see the original doesn't get changed. Huzzah! See there? My original object stays unchanged. Okay, so I still get to play with the object in my function, but it remains unchanged. Okay, so that's always the kind of thing you want to think about when you're playing with arrays and objects. Because another place where this becomes an issue is if you think you want to make a copy. So here I have my obj, and I want to make a copy of my obj, so I do my obj2. Okay, so I'll just do const my obj2, and that's why the const works with an object. You can edit the individual elements inside of an array or an object, even though you declare with a const, because you're not editing the reference. The reference stays the same. You're just editing what's inside the address, but you're not changing the address. That's the constant variable, and that's why it behaves that way. Okay, so I go my obj2 equals my obj, and then what I do is I decide to change my obj2 dot name is going to now equal Hector Merced, and then I'm going to console log both of them. My obj, which was originally Alex Merced. Okay, and the reason I'm using both names is because my full name is Hector Alexander Merced, but my obj, context is everything. My obj2. Okay, and you'll see my obj. I only assigned Hector Merced to my obj2, not to my obj. But when I console log both of them, let's see what happens. They're both Hector Merced. Why? Because all I did was, when I say my obj2 equals my obj, it's just copying over the address. So now you have two variables pointing to the same address in memory. So if I edit both of them, it's going to change the same object. Okay, there's only one object that was created, and I'm just passing the memory into different variables. Okay, so that's why it's important to understand when are you assigning a value versus assigning a reference. Now, if I wanted to kind of avoid that, just do what I was saying before. You put curly brackets around it, put 3 dots, the spread operator, and that will basically what you're doing now is you're creating a new object with the same properties inside of it, and you're passing over the reference to that new object. Okay, so now it's a new address, not the same address. So when I do that, see, now they're different. See, the original myobj stays the same, and the new myobj gets the change, or myobj2 gets the change. So these are just all sorts of little things, little tweaks or little concerns you have to worry about when JavaScript is like dealing with your data, making sure your data behaves the way you expect it to, or why it isn't working the way you expect it to, and how you can fix it without having to do anything super crazy. Because oftentimes people do like super crazy things to try to work their way around these things, when oftentimes the solves are pretty simple.